Hi everyone, and welcome back to episode 2 of Reefing with Raspberry Pi. In today's episode, we go through version 1.2 of our code still in its alpha stage, where we introduce the OLED to the relay control program. I've left the link in the description below to episode 1, where I describe the hardware used in the project. Thanks to everyone who showed their support, and I hope you're as excited as I am to automate with Raspberry Pi. In today's video, we'll be looking at a UC-Tronics OLED module with a 128 by 64-bit resolution. The unit has dual color and is self-luminous. I purchased this OLED on Amazon, and the link can also be found in the description below. Well, without further ado, let's jump right in. After powering on the Raspberry Pi, we'll want to download the SSD 1306 drivers from the Adafruit website. On Raspberrian, we'll do that through the Git cloning. I'll leave the link in the description below. This is that website. First, we'll open the command line and navigate to your download directory of choice. Next, we'll issue the command git clone and the URL you collected from the link below. After a few seconds, the download should be complete and viewable through the file manager. The drivers come with examples, and I highly recommend testing them out to familiarize yourself with the interface. As you can see, when we run the SSD 1306_stats, the OLED display changes. This is a great way to ensure that you have all the necessary libraries to continue on. If you run into errors when attempting to execute one of the scripts, visit the learn.adafruit.com website. Link will also be in the description below. They have a great article called Python Usage. The same article was used to create our version 1.2 of the alpha script. With introductions out of the way, let's take a look at version 1.2 of our code. Before we jump right in, here's a refresher screenshot of the components we'll be using for the OLED script. The OLED has been configured to display the following. First, a loading screen during the initialization of the GPIO. Keep in mind, for presentation purposes, I have added delays. Many of these transactions can be performed by the Raspberry Pi almost instantly. Second, we've added an idle screen similar to our console main menu. The idle screen is reflective of the system waiting for the user to input a selection. Third, program state screens have been added to reflect when a relay is on or off. The fourth and final addition is the GPIO cleanup screen. Let's see them in real time before diving into the code so you can experience it for yourself. The first thing you'll notice on the Raspberry Pi is that there's an enabling GPIO loading screen. This is to indicate the GPIO. Then the job completes. We're then presented with the program idle screen and our main menu. The mode is set to manual. In future releases, we'll be configuring schedules. The program is awaiting input. We'll make our selection for relay 1. And now the program is active with relay 1 is on. When the relay turns off, the program will return back to the idle state and indicate relay 1 is off. After a few seconds, the LED will return back to the main menu where the program is idle and it's awaiting input. If we select the second relay, a similar action occurs. The program displays active, mode manual, where relay 2 is on. Once relay 2 is turned off, the program returns back to idle, and then after a few seconds the script returns back to the main menu. if we make our exit selection, the GPIO cleanup process loads. There's a in progress screen, and finally you'll see the job completed and a clearing of the screen. So now that we've seen the demo, let's jump right into the code. I've got the new 1.2 and also 1.1 displayed on the screen. First, let's talk about the changes. We have OLED configuration library imports. We are now importing board and digital I/O, along with pill, import image, image draw, and image font. We're also importing Adafruit. As we scroll down, we set our reset pin, assign our OLED dimensions, the hardware address, and the reset pin. OLED equals Adafruit underscore SSD 1306. This line of code is very important. When I configured this, my address was OX3D. And whenever I attempted to run the script, I would run into errors. Let's see if we can display that. Ew. It's a very easy fix, and the example code uses OX3D. Simply just change it to OX3C, which is the hardware address for this particular OLED. The first thing that happens after we assign the OLED dimensions and the hardware address is that we clear the display by filling the OLED with the 0 bit. We then show that display. We initialize the fonts for future use. I'm using Quicksand Bold. And then there's some configuration from episode 1, as you can see here. This is all the GPIO setup. So, we move on to the program loading simulation. This is where things change. The first thing you'll notice is that the OLED loading screen begins to appear. There's some draw console and OLED cleanup text. This lets us know that we're enabling the GPIO. And then we display that image using OLED period image and hand it image 12. On the right, in our old code, you can see the main menu and the loading screens that were appearing on the console. They're just simple print statements with timers. One thing I did forget to mention, if you want to use the time.sleep, you'll need to import the time library. So make sure you do that. Now, what I've done is I've configured the draw on the OLED to honor the sleep times that we see in the original code. As you can see, you have sections of the code as there is a printout. So my draws are drawing to my OLED, while my prints are printing to my console. There is a single timer to sleep and pause or delay before moving on to the next print. As it moves to the next print, another image is created for the draw, and then that image is displayed using the OLED.image and handing it image 13. Please keep in mind that every image is unique. We start with image 12 and then image 13. The next is image 14, and the next is image 15. And as we go through this step, we're seeing a simulation of a loading screen. First with 2 periods, then with 3 periods, then with 4 periods, and and finally the job completing. The relay selection program is a function I configured called program_loop. On the right hand side you can see it's a simple GPIO command, and then a print, and then a sleep. I have added some draw text to this, and as you can see, once again I filled the OLED with all 0 bits to clear the screen. I display that with the OLED.show command, and then I create my first image, and I begin drawing my text one more time. Now you can see the idle program state and the awaiting input. I take that draw that I just submitted a command for, and I show it on image 11 and call the program equals input. There's a relay 1 manual control. If the program reads 1, we create a blank image. 1 for on, 2 for off, and we use them for drawing. So image equals image.new. We set the relay to on or low, and then we print to the console relay 1 on. At the same time, we're drawing to the OLED, notifying the user that the relay is on. Once again, we show that image, and then we put a 10-second sleep timer to allow for the user to read the current state without it disappearing. That relay is then turned off, and once again, another image is generated, image 2. Here we're drawing the off text. We then show that image again on image 2. That was relay 1. If 2 is pressed, or if 3 is pressed, that follows the same structure. 2 images are drawn, creating blanks for image 3 for on, 4 for off. As you can see, I have image 3 for on, and I have image 4 for off. For controlling channel 3, I'm using 5 for on and 6 for off. So you can see the pattern. Image 5 for on, image 6 for off. Finally, once we get to GPIO cleanup or option 4, the else if program or statement creates a blank image for GPIO cleanup, 7 for active and 8 for complete. We then print to the screen that we're cleaning up the assignments and draw those to the OLED, before finally displaying them and repeating the process. At the very end, once we're all done, we raise the system exit. And that's it. Don't forget to like and subscribe if you enjoyed this video and you found it helpful. Thanks for joining me, and I'll see you next time.